to KUTV ELIMU Live. My name is Teacher Kelvin Fudi Wanyabura, and today we are going to study a very interesting subject, and the subject is mathematics. The subject is mathematics. And we are going to study another very interesting topic. The topic is longitudes and latitudes. It is a Form 4 topics. It is a Form 4 topic, longitude and latitudes. Longitudes and latitudes. As usual, as we start our lesson, we always start with the word of prayer. Father, in the name of Jesus Christ, we thank you for this day. Thank you for this lesson. Bless us and the student. In Jesus' name we pray. Amen. Now, on longitudes and latitudes, we are going to start with the position of a place on the Earth's surface. Position, that is our first subtopic. Position of a place on the Earth's surface. Position of a place on the Earth's surface. On the Earth's surface. Now we're going to have a drawing of a globe. That is the Earth's surface. That is the Earth's surface. On the Earth's surface, we have what we call the equator, that is 0 degrees. The equator divides the latitudes into two equal parts. We have the northern side and we have the southern side. So all the points that are on the northern side, they are called latitudes on the north. All the points on the southern side, they are latitudes on the south. Then the equator is always 0 degrees. So latitudes are the lines moving from east to west, and they are either on the north or south of the equator. Then we have what we call the Greenwich meridian or the prime meridian. This is called the Greenwich meridian, which is 0 degrees. The Greenwich meridian divides the longitudes into two equal parts. We have the eastern latitudes and we have the western longitudes. Sorry, not latitudes, longitudes. We have the eastern longitudes and the western longitudes. So the topic, remember, it is longitudes and latitudes. We first understand what are latitudes. Latitudes are either the lines on the north or south of the equator. Longitudes are either the lines on the east or west of the prime meridian, where the prime meridian is always 0 degrees and also the equator is always 0 degrees. Now, when we are looking at the position of a place on the Earth's surface, we always start with the latitude. We always start with the latitude. So this is how we write the position. Latitude, we state the latitude, then comma, we state the longitude. We state the latitude, then we state the longitude. Now, I want us to look at our diagram here. We look at our diagram here. This diagram has the equator, has the Greenwich meridian, and it has the latitudes and the longitudes. So if here it's 50 degrees, if we have 50 degrees here, and then here maybe we have 40 degrees, this means that the latitude is 50 degrees north. This means that the latitude is 40 degrees south. If then they say that this line is 55 degrees and this other line here is 48 degrees, this means that this line, every point on this line is 55 degrees east. Every point on this line is 48 degrees west. So let's say now we have point A here, we have point B here, we have point C here, we have point D here, we have point E here, and we have point F here. Now, I want us to state together the position of all these points. We want to state the position of all these points. Now, point A. Point A is 50 degree. Point A is on 50 degrees west. The longitude is 50 degrees west. Point A is on the latitude. The latitude, the longitude is 48 degrees west. The latitude is 50 degrees north. That is point A. That is point A. Now, how do we name point A? We start with the latitude. Point A is it on the north or is it on the south? Point A is on the north of the equator. Now, on that north, what is the value on that line that is on the north? The value is 50 degrees. So we'll have 50 degrees north, comma, we ask ourselves, is point A on the east or on the west? Point A is on the west. Point A is on the west. And that line where point A lies on the west is 48 degrees. So our point A will be 50 degrees north, 48 degrees west. That is point A. Now, my dear students, we move on to point B. Point B is on the north, and the line where point B lies is 50 degrees. The line on the north where point B lies is 50 degrees. So you'll say 50 degrees north, comma, the line on the east where point B lies is 55 degrees. 55 degrees east. That is point B. We move on to point C. Point C is at the equator. Point C is at the equator. So if point C is at the equator, it means that point C is 0 degrees. And if a point is at the equator, we don't state whether it is north or south because it is at the equator. And at the equator, it is always 0 degrees. It is always 0 degrees. So point C is at the equator. That is the line that divides both the latitude on the north and on the south. Then it is on the west side. And the line on the west side is 48 degrees. So point C is 0 degrees, comma, 48 degrees west. That is point C. We go to point D. Again, point D is at the equator. So 0 degrees, comma, point D is at the equator, 0 degrees, comma. Point D is on the north, on the east side. On the east side, and the line where point D lies on the east side is the line that is labeled as 55. So, comma, 55 degrees east. We continue. Point E. Point E is on the south of equator. And also it is on the west of the Greenwich meridian. The line where point E lies on the south of the equator is 40 degrees. So we write 40 degrees south, comma, the line where point E lies on the west side is 48 degrees. This line that we labeled 48 degrees. So 48 degrees west. Lastly, we have point F. Point F is on the south of the equator, and it lies on the line 40 degrees south. This line, 40 degrees south. So you write 40 degrees south, and it is on the east side. It is on the east side of the Greenwich meridian, and the line where it lies on the east side of the Greenwich meridian, it is the line labeled 55 degrees. This line, that is where F is. So F is 40 degrees south, 55 degrees east. 55 degrees east. And my dear students, that is how you are able to get the position of places or points on the Earth's surface. That is the first important thing to note. We start with the latitude. The latitudes. You see which latitude does that point lies on. Then longitude. Which longitude does that point lies? You state the latitude and you say whether it is north or south. Then you state the longitude and say whether it is east or west. East or west of mathematics, not the one of east or west, home is the best. Now, we come to another subtopic, important subtopic, great circle and small circle. Great circle and small circle. Great circle and small circle. Great circle. Great circle, and thank you, my dear students, as you continue watching KUTV ELIMU Live. We are now on great circle and small circle. Now, how do we know whether 2 points on the Earth's surface makes a great circle or a small circle? Great circle. We start with the great circle. Great circle. Then we'll say points are said to form a great circle, if and only if 1, the latitudes are 0. The latitudes are 0. The latitudes are 0. Another circumstance for it to be a great circle is if the longitudes are the same. The longitudes are the same. The longitudes are the same. Then we go to small circle. When do we say that points form a small circle? Small circle. Small circle. Points are said to form a small circle if points forms a small circle, if and only if the latitudes are not 0, the latitudes are not 0, and the longitudes are not the same. So in other words, my dear students, a great circle, like here we have A, B, C, D, E, F. I want us to see which points make a great circle. We'll only say 2 points are making a great circle if and only if the latitudes, both latitudes are 0. Both latitudes are 0. Or if both latitudes are not 0, the longitudes are the same. And remember, we said the latitudes are the first ones, the ones with north and south. The longitudes are the second ones, with the ones with east or west. So, my dear students, let us select the great circles here. I know you are watching me back at home or in school, and I believe that you have noted already right now, as I have noted, the great circles in our 6 points here. My first great circle here is C and D. C and D. C is 0 degrees 48 degrees west, and D is 0 degrees 55 degrees east. Therefore, we will call these a great circle because, my dear student, the latitudes are 0. Another example of a great circle from our points here, great circles, where the longitudes are the same. Where the longitudes are the same. A and B are not great circles. The longitudes are not the same and the latitudes are not 0. B, C are not great circles because longitudes are different, latitudes are not 0. One of them is not 0. So, where do we get a great circle, my dear student? I can see one. I can see point A and E. A and E. That is another example of great circle. A, 50 degrees north, 48 degrees west, and E, 40 degrees south, 48 degrees west. It is a great circle because the longitudes are the same. Another example of a great circle from here is, let me see, we have B and F, BF, BF. B, 50 degrees north, 55 degrees east, and F, 40 degrees south and 55 degrees east. This is a great circle, my dear student. Why? The longitudes are the same. So up to there, my dear student, I believe that you have understood when points are said to be great circles. Let us have examples of small circles from our point there. Examples of small circles. Examples of small circles. A and B are small circles. A and B. A, 50 degrees north, 48 degrees west, and B, 50 degrees north, 55 degrees east. I'll just give 2 examples of small circle. Another small circle, the reason we say A and B is a small circle is because A has 48 longitude, 48 degrees west. Longitude for B is 55 degrees east. So the longitudes are not the same and the latitudes are not 0. Therefore, it makes it a small circle. Let us see another example of a small circle. We have B and E. B, Let us see another example of a small circle. We have E and F. E, 40 degrees south, 48 degrees west, and F, 40 degrees south, 55 degrees east. This E and F qualifies to be a small circle, reason being the latitudes are not 0 and the longitudes are not the same. There is something, my dear student, I want you to note about the latitudes of small circles. The latitudes of small circles are the same. Don't confuse what are latitudes, the first ones. So, small circles are formed if the longitudes are not the same and the latitudes are the same but not 0. That is a small circle. Longitudes are not the same and latitudes are the same but not 0. Great circle, either the longitudes are the same or the latitudes are 0, both of them. That is how you determine a great circle and a small circle. The next subtopic. Now, we want to look at another good example. Now, we want to go to now distances so that we can do examples. And thank you, my dear students, for continuing watching us on KUTV ELIMU Live. As we now get to the next one, distance. One, we'll start with distance along a great circle. And we'll still use the examples we mentioned for great circle. Distance along a great circle. Formula for distance along a great circle. We start with 1 in kilometers. Distance in kilometers. Distance in kilometers along a great circle is theta over 360 2 pi r, where r is the radius of the earth. And the radius of the earth is mostly given as 6,370 kilometers. That is in kilometers. Distance along a great circle in nautical miles. In nautical miles. Distance is given by theta times 60 degrees, or theta times 60. That is distance in nautical miles. So, my dear student, I know you are asking yourself, now that I've told you r is the radius of the earth and is always 6,370 kilometers. What about theta? What does theta represent? 1, where theta, let us write, where theta is the longitude difference, where theta is the longitude difference in circumstance 1. In circumstance 1. Remember kuna circumstance. Remember that we have 2 circumstances. And again, theta is latitude difference. Theta is latitude difference in circumstance 2. Difference in circumstance 2. What do I mean, my dear student? Circumstance 1 is where we said that a great circle is the circle where the latitudes are 0. So if you have a question where the latitudes are 0, our theta will be the longitude difference. That is circumstance 1. If we have a case of a great circle where it became a great circle for having similar longitudes, theta will be the latitude difference. Circumstance 1 is a great circle where the latitudes are 0. Theta in that case is the longitude difference. Circumstance 2 of a great circle is where the longitudes are the same. Theta in that case will be the latitude difference. That is distance along a great circle. Now we go to distance along a small circle. Distance along a small circle. Distance, I can erase this. I believe that you've gotten it now. We go to distance along a small circle. Distance along a small circle. Distance, that is now number 2. Distance along a small circle. Distance along a small circle. So, my dear students, these are the formula. In kilometers, along a small circle, Distance is given by alpha over 360 2 pi r cos theta. That is in kilometers. In nautical miles, distance is given by alpha times 60 cos theta. Now, after this, we are now going to do some examples where alpha is the longitude difference, alpha is the longitude difference, and theta is the common latitude, and theta is the common latitude, and theta is the common latitude. R, you know, R is still the radius of the earth, which mostly is given as 6,370 kilometers. This is a small circle, distance along a small circle. My dear students, we want to have some examples, but before we have examples, I want us to cover another important concept: longitude difference and latitude difference. How do we get them? Because we have said alpha is the longitude difference. How do we get it? So, longitude difference and latitude difference. Longitude difference and latitude difference. Longitude difference and latitude difference. So, my dear students, to get the longitude and latitude difference, if the points or the points where you are looking for the difference are on the same side, if they are on the same side, we subtract. If the points are on the same side, we subtract to get either the longitude or latitude difference. For example, my dear student, the longitude difference between 55 degrees east and 48 degrees west, we cannot subtract because one of it is east, the other one is west. If they are both east, if both longitudes are in east, we subtract to get the longitude difference. If both of them are west, we subtract to get the longitude difference. The same applies for latitude difference. If both latitudes are in the north, we subtract. If both latitudes are in the south, we subtract. Same side, we subtract. If they are on different sides, we add to get the longitude and latitude difference. For example, the latitude difference between point A, which is 50 degrees north, 48 degrees west, and point F, which is 40 degrees south, 55 degrees east, will be 50 degrees plus 40 degrees, because one of them is in north and the other one is in the south. So if they are on the same side, we subtract, and if they are on different side, we add. All right, we get now to examples. So in the exam, you will not be told that this is a small circle. For you to know the formula to use, it is for you to identify whether it is a small or a great circle, because the formula for the small circle and the formula for the great circle, they are different. So example number 1, find the distance find the distance in kilometers and nautical miles between A, point A, which is 50 degrees north, 48 degrees west, and point B, which is 50 degrees, 40 degrees north, 48 degrees west. These are different examples from the points that we had. We are not using the points that we had. That is part A. Let us solve part A. Solution. Now, my dear student, the first thing for the solution is this a great circle or a small circle? This is a great circle. Reason being, the longitudes are the same. Both of them are 48 degrees west. Circumstance 2 of great circle. Therefore, the distance in kilometers will be given by theta over 360 times 2 pi r. Now, my dear student, what is our theta? Theta is the latitude difference, because we said for circumstance 2, theta is the latitude difference. Now, what are the latitudes of these points? 50 degrees north and 40 degrees north. Are we going to add or subtract to get the latitude difference? We are going to subtract because they are both on the same side. They are both in north. Therefore, our theta, which is the latitude difference, will be 50 degrees minus 40 degrees. Our theta is 10. Therefore, we can apply our formula. So, distance is theta 10 degrees over 360 times 2 times pi 22 over 7 times the radius of the earth. If not given in the exam, you always know that the radius of the earth is 6,370 kilometers. 370 kilometers. Then, using your calculator, my dear student, I know you are having your calculator there, as I am also having my calculator here. Let us calculate together. So 10 over 360, 10 divided by 360 times 2 times 22 over 7 times 6370. The distance is 1112.22 kilometers. And you finish and you go to the next part of the question. That is distance in kilometers. Distance in nautical mile. Let me erase this one now so that we can do. Distance in nautical mile. Distance in nautical mile. So, in nautical miles, distance along a great circle is theta times 60. So distance will be, already we have gotten theta as 10. Remember, we are on the same question. Theta is 10 degrees. So in nautical mile, simply it is 10 multiplied by 60. And then you'll get distance as 600 nautical mile. That is part A of the question. I believe that, my dear students, you are understanding as we get to the next example. Thank you for watching KUTV ELIMU Live. We go now to part B. P, distance between P, 40 degrees south, 50 degrees east, and Q, and Q 40 degrees south, 45 degrees, not 45, 25 degrees west. Now, again, my dear students, we get here. What is the first thing that we need to know here? Is it a great circle or a small circle? My dear student, is it a great circle or a small circle? It is a small circle. Reason being, the longitudes are not the same and the latitudes are the same but not zero. The longitudes are not the same and the latitudes are the same but not zero. It is a small circle. Therefore, in kilometers, we will have the formula. Distance is alpha over 360 2 pi r cos theta. In nautical miles, we'll have distance as alpha times 60 cos theta. Where we said alpha, we get alpha. Alpha is the longitude difference. Alpha for small circle, alpha for small circle is longitude difference. Are we going to add, my dear students, or are we going to subtract? We are going to add. Reason being, one of the longitude is in east and the other one is in west. If they are on different side, we subtract. We add. If they are on different side, we add. So our alpha will be 50 degrees plus 25 degrees, which will give us 75 degrees. Theta is the common latitude. Common latitude means the latitudes are the same and both of them are 40. Therefore, theta is 40 degrees, my dear students. Therefore, distance in kilometers will be alpha, which we got by taking 50 degrees plus 25 degrees, which is the longitude difference, and we added because they are on different side. That is alpha 75 degrees over 360 times 2 times pi times r 6,370 cos theta, which is the common latitude, 40 degrees. 40 degrees. Therefore, our distance, as also you are using your calculator, my dear student, I'm also using my calculator here. Let us see how we get that distance. 75 degrees over 360, 75 divided by 360 times 2 times 22 over 7 times 6370. No, it's not 6370, 6,370 times cos 40 degrees. I am getting the answer as 6,390.09 kilometers. That is a distance along that small circle in kilometers. We said it is a small circle because the latitudes are the same but not zero, and the longitudes are not the same. Distance in nautical miles will be alpha. We have already gotten alpha here as 75 degrees. Alpha times 60 cos theta. Cos theta, our theta is 40 degrees. Therefore, our distance in nautical miles is 75 times 60 times cos 40, which is our theta, 3,447.20 nautical miles. That is distance in nautical miles. Now, my dear students, before we go to the other concept of longitude and time, we want to do part C of the question. We want to have part C of the question. Point X 0 degrees 72 degrees east and y 0 degrees and 21 degrees east. So, my dear students, is this a great circle or a small circle? Is this a great circle or a small circle? It is a great circle. Reason being, the latitudes are 0. Therefore, it belongs to the great circle circumstance 1, where the latitudes are 0. Therefore, we're going to use the formula of great circle. So, in kilometers, distance will be theta over 360 2 pi r, and in nautical miles, which we'll do later, it is theta times 60. Now, how do we get theta? For circumstance 1 of great circle, theta is the longitude difference. Theta is the longitude difference. Now, this is 72 degrees east, my dear student. This is 21 degrees east. Are we going to add or subtract? We are going to subtract because both of them are east. 72 degrees minus 21 degrees. And this one will give us 51 degrees. That is our theta. R is the radius of the earth, 6,370 kilometers. Now, our distance in kilometers will be 51 over 360 times pi 20 times 2 times pi 22 over 7 times 6,370 kilometers, which is the radius of the earth, So we get it. 51 degrees divided by 360 times 2 times 22 over 7 times 6,370. It will give us 5,672.33 kilometers. In numerical miles, we have very simple. In numerical miles, distance along a great circle is theta times 60. So this will be 51, which we got here, multiplied by 60, which will give us 51 multiplied by 60. It is going to give us 3,060 numerical miles. And that is how you're supposed to calculate distance along a great circle or distance along a small circle in both kilometers and numerical miles. I believe that you note the difference in the formulas for a great circle and the formula for the small circle. In great circle, we have two circumstances where the latitudes are 0, circumstance 1, and where the longitudes are the same, circumstance 2. And for the small circle, we have only one circumstance, that the longitudes are not the same, the latitudes are the same, but not 0. NB, not barrel. 1 nautical mile is equivalent to 1.853 kilometers. 1 nautical miles is equal to 1.853 kilometers. That one is used when converting kilometers to nautical miles or nautical miles to kilometers. So the last part of the topic is longitude and time. Longitude and time. Longitude and time. Thank you once again, my dear student. Continue watching Teacher Kelvin here in KUTV ELIMU Live Mathematics. Now, we got to longitude and time. Okay, longitude and time. Now, longitude and time. The concept here that we need to know on longitude and time is, the concept is the difference in local time between 2 points. Difference in local time, difference in local time, difference in local time is given by longitude difference times 4 minutes. Longitude difference times 4 minutes. Then, something to note better here is, something to NB here is, once you get the difference in local time, if moving eastwards, you add. When moving eastwards, when moving eastwards, we add the difference in local time to the time given. When moving westwards, we subtract the difference in local time. We subtract the difference in local time from the one given. We subtract the difference in local time from the one given. Those are important concepts. Let us have an example of difference in local time. Let us have an example. So example. A 30 degrees north, 45 degrees east is see. So example 1, if the local time at A 30 degrees north, 45 degrees east is 1:00 p.m. Determine the local time. Determine the local time of B, which is 30 degrees north and 65 degrees east and 65 degrees east. So that is how the question reads. Our question reads, if the local time at A, which is 30 degrees north, 45 degrees east, is 1 p.m., determine the local time of B, which is 30 degrees north, 65 degrees east. Solution. My dear student, the first thing to get is the longitude difference. The first thing to get there is the longitude difference. So you get the longitude difference, longitude difference. And the longitude difference, are we going to add or subtract? Are we going to add or subtract? I know you are answering back at home. 45 degrees east, 65 degrees east. We are getting the longitude difference. We are going to subtract because both of them are in east. 65 degrees minus 45 degrees. That gives us 20 degrees. That is the longitude difference. The next step is get the difference in time. Difference in time. We said the difference in time is given by longitude difference which is 20 degrees in our case, multiplied by 4 minutes. That is the formula. Longitude difference multiplied by 4 minutes. Longitude difference we subtracted because they are on the same side. Now, our difference in time will be 20 multiplied by 4 is 80 minutes. Now, you have to convert the minutes into hours and minutes, or into hours. You divide by 60. You divide by 60 minutes. Here, you're going to get 1 hour, 20 minutes. So the difference in time between point A and B is 1 hour, 20 minutes. Now, what is the local time at B? The local time at A is 1 p.m. The local time at A is 1 p.m. Ask yourself, moving from A to B, are we moving towards the east or west? A is 45 degrees. A is 45 degrees east. And we are going to B, which is 65 degrees east. Are we moving eastwards or westwards? We are moving eastwards because in A, it is 45 degrees east. In B is 65. So this one is an eastward that is greater than this. Where we are going, it is on the east that is greater than from where we are given the time. So where we are given the time is 45, where we are going is 65, and both of them are east. So this means that from A to B, we are moving eastwards. Therefore, we add the difference in local time to get the local time at B. So we add 1 hour, 20 minutes. We add 1 hour, 20 minutes. We add 1 hour, 20 minutes, and this will give us 2:20 p.m. My dear students, the local time at B, is 2:20 p.m. In our next lesson, we will do a 10 marks example. My dear students, thank you so much. We have been together for that time as we were learning longitudes and latitudes. And before I conclude, my dear students, I have 3 books. My first book is Never Give Up, Never Give Up, a play on overcoming challenges of life. We have With God All Is Well. With God All Is Well, it is a novel. And most importantly, for a mathematics master like you who is watching me, you need Boosting Mathematics Performance KCSE Mathematics Revision book. If you need a copy, especially of this mathematics revision book, you can contact me via 0705 845 747. 0705 845 747. Never Give Up, my first book. We have With God All Is Well, my second book. And we have Boosting Mathematics Performance, the most important KCSE mathematics revision book by Teacher Kelvin. Thank you, my dear students, for watching this lesson. Thank you so much, and may God bless you abundantly, and always remember to pray when doing everything. My name is Teacher Kelvin Fudi Wanyambura. God bless you.